Good morning. Yeah, this is our first mass lesson through the media. Of course, we know we've been having the issue of coronavirus, which has affected our learning, of course, in many schools. So we thought as directed by the ministry, we have a class, of course, now through the media. This is our first class and our first mathematics class. This is Bokolsun High School, Form 4, 2020. And of course, now we are calling our first class, we are giving our first lesson, mathematics basics. So we just want to go through the basics, which I believe will help us be able to do well in maths. So just to mention a few things, we have some topics which I consider to be basics, meaning if at all you have an issue with these topics, most likely you are going to struggle throughout in mathematics. So the topics, some of them are in Form 1, a number are in Form 2. For example, the first topic in Form 1 called natural numbers is a must know for any student. Now, fraction, Form 1, another topic. We have decimals, we have integers, we have LCM and GCD. All of them are in Form 1. We have algebraic expression, we have linear equation, still in Form 1, measurement 1, angles and plane figures, geometrical construction, all again in Form 1. Then we have indices in Form 2, quadratic expression and equation in Form 2 and Form 3. So we are saying if at all you find any student having a challenge in maths, most likely the challenges come from these main topics. So if you are to minimize your problems in mathematics, make sure the topics I've mentioned, at least you know something about them. Are we together? Now for today, we are going to focus on a topic called quadratic expression and equation. Of course, the first bit of the topic is found in Form 2. The second bit of the topic is found in Form 3. Are we together? Now this is a topic which, if at all you have an issue with, you're going to find a lot of problem. Let me give an example. We have a topic called calculus in Form 4. Now, in solving problems to do with calculus, we'll find a number of course, questions requiring what? The concept of quadratic expression and equation. You go to graphical methods Form 3, last topic in Form 3, you find a number of questions requiring what? The concept of quadratic expression and equation. Meaning, if at all you'll have a problem with this topic, now you're going to have what? Problems almost throughout your entire, of course, now secondary, of course, now syllabus in mathematics in terms of how you understand it. Are we together? So today we look at what? Quadratic expression and equation. And now, to begin with, the first thing we're going to look at is what we call what? An expression. Because now we normally have this key problem. Students don't know to differentiate between an expression and an equation. You find that they are given an equation, they treat an equation as an expression, they get it wrong. Sometimes they are given what? An expression, they treat an expression as an equation. So just to avoid such problems, we need to clarify what is an expression and what is an equation, and how do you identify them in a given question. So we begin with what? An expression. So put down the following in terms of this definition. An expression is a mathematical statement that has only one side. I will repeat. An expression is a mathematical statement that has only one side. And of course, I'm going to give examples The first example is this, x plus 3. So x plus 3 is an example of what? An expression. If you're very keen, it has only one side. Now, another example will be x plus y. So we have x plus y being a second example of what? An expression. Another example would be x squared plus 4x. And then the last example would be x cubed plus 3x squared. Now, if you're very keen, I've given 4 expressions. Now, these expressions are of different types. Now, x plus 3 and x plus y. If you look at the variables x and y, the highest power there is what? Power 1. So having power 1 as the highest power in a given expression, we call it what? A linear expression. So x plus 3 is what? A linear expression. X plus y is a linear expression. Now, whenever you are given an expression and you find power 2 somewhere being the highest power, that expression now does not qualify to be what? A linear expression. What do you call it? A quadratic expression. Then, when we have power 3 being the highest power, what do you call that? It's called a cubic expression. So, in summary, we have said what? An expression is a mathematical statement that has what? Only one side. We can have a linear expression like the first two I've shown here. We can have a quadratic expression. We can have a cubic expression. Are we together? Then we look at what an equation is, and if possible, give what? Examples, and see how an expression differs from an equation. So we discussed that. So we have an equation. So what's an equation? Just having a little challenge here, I think. No, we're going to overcome it in a short while. Okay, so we go to an equation. Now, what's an equation? An equation is a mathematical statement that has what? Two sides connected by an equal sign. So expression has only one side. An equation has two sides connected by what? An equal sign. Now, from this expression I've given here, I can form what? Various equations. For example, x plus 3. The moment I add the equal sign, and then I have what? X plus 3 is equal to 6. It becomes what? An equation. Initially it was what? An expression. What type of expression? It was a linear expression. Now I end up with what? A linear equation. Now I'm having another linear expression here. The moment I add an equal sign, then put a number after the equal sign, becomes what? An equation. For example, now we have what? X plus y is equal to 7. Initially it was what? X plus y. It was a linear expression. Now, by adding the equal sign and adding 7 becomes what? A linear equation. Now, here we have what? X squared plus 4x. What is this? A quadratic expression. But the moment I add an equal sign, then of course a number or maybe a letter becomes what? An equation. For example, I have what? X squared plus 4x is equal to 0. Now we have what? A quadratic equation. Now we go to the last one. Here we have what? At the moment we have a cubic expression. Now I'm going to add equal to 6. Now that changes from an expression to an equation. Are we together? So in the previous case we had what? expressions here. Now what do we have? We have equations. A linear equation, another linear equation, a quadratic equation, and a cubic equation. Are we together? So we are saying you must know the difference. At the moment, what is the difference? An expression has only one side. What about an equation? An equation has two sides connected by an equal sign. So I'm saying to avoid that challenge of treating an equation as an expression or treating an expression as an equation, you must know what? The difference. So at the moment I've said what is the key difference? Expression has one side. An equation has two sides. Now we want to see another difference. Another difference will be in terms of how the questions are framed in the exam. A question will tell you by the language used there, you're dealing with an expression or you are dealing with what? An equation. Let's be able to see that. We'll be able to see that in a short while. Now, if at all you are dealing with what? An expression. Where we don't have what? Two sides. We don't have what? The sign of inequality. So the keywords will be what? Expand, simplify, or factorize. I just want to make sure you get that right. So the words to indicate that you are dealing with what? An expression are three keywords. Number one, what is the word? Expand. So we have what? Expand. Number two, what do we have? Simplify. The moment you see simplify in a question, automatically just remember what are you dealing with? You are dealing with an expression. Number three, keyword to show that we are dealing with an expression is what? Factorize. So it's either expand, simplify, or factorize. You see those three keywords, what should be in your mind? I am dealing with an expression and not an equation. Now, what about an equation? How do you know that I'm dealing with an equation? Only one keyword, that will be solve. We don't solve expression. What we solve? We solve equations. So, the moment you see the keyword solve. Sorry? Solve. Solve means what? You are dealing with what? An equation. We are saying this is a very key problem. Of course, in terms of how the question is answered by students in the main exam. You give a student an expression, you find them giving a solution, and yet the question did not require you to solve. You give them an equation, they end up with what? An expression, and yet the question wanted what? A solution. So we are saying be very keen. If an expression, what do? You either expand, simplify, or factorize. What about an equation? For an equation you solve. Now we want to see how this has been tested in the past. Of course, now in a short while. Look at KCSE 2002. We had a question in paper 1. The question was, of course we have it there, but I'm going to write the question here for clarity. KCSE 2002, paper 1. We had a question. Now, as a student, the moment you see simplify, what should be in your mind? What are you dealing with? An expression. So, for this question, if you end up with something like this, just giving an example, if you end up with something like x is equal to this or y is equal to this, automatically you are wrong. Because we are dealing with what? An expression and not an equation. Whatever we have as x is equal to 4 or y is equal to 6 should be what? The end result of a quadratic, or let me say an equation whereby you are solving. Are we together? But the moment you're told simplify, this should not be your end what? Your end result. Something we shall look at later. Now, let's look at KCSE. Of course, now another question. 2011, we had a question in paper 1. This was the question, which of course is projected there, but I'm going to have it written here. Now, what is the question? Factorize. The question was factorize what? So KCSE 2011, we had that question in paper 1. Factorize 2x squared y squared minus 5xy minus 12. Implying what? We are dealing with what? An expression and not equation. Of course, later we shall see how that is what? Achieved. We go to KCSE 2018. Again, paper 1. The question was expand and simplify. So again, I'll have it here. We have expand and simplify. So we have 2x plus 1 squared, x minus 1, x minus 3. That was what? A question dealing with what? An expression and not an equation. Because I said, what are the keywords indicating you are dealing with an expression? Expand, simplify, and factorize. Now, lastly, we look at another question. Now, there are 2 more questions to look at. KCSE 2013. The question was again, simplify. We have it there. I'm going to make it, of course, now clear. The question is what? Simplify, of course, now 16. The question was simplify 16m squared minus 9x squared over 4m squared minus mn minus 3n squared. Meaning what? This is an expression. But now you're saying it's a very common mistake. You give a student such a question, they end up with something like what? N is equal to 4. N is equal to 6. That is wrong. We are saying for an expression, that should not be what? The end result. Are we together? Now, we look at the last question in KCSE 1991. Again, paper 1. What is the question there? Solve. So 1991, paper 1, the question was solve. Solve for x. Then you are given that. Meaning what? Now I am dealing with what? An equation. Are we together? So you only solve an equation. You don't solve an expression. So I hope now we are okay with what? The difference between what? An expression and an equation. In summary, expression has only one side. An expression can be a linear expression, quadratic expression, or a cubic expression. An equation has 2 sides connected by an equal sign. We can have again a linear equation, quadratic equation, or cubic equation. What do you do to an equation? You solve. What do you do to an expression? You expand, simplify, or factorize. So I think we're done with the first part. Let's go to the next part. So next part now will be focusing on what a quadratic expression is. Because we have agreed that we've got what? Different types of expression. We have a linear, we have, of course, quadratic, and we have what? A cubic. For now, our focus will be to discuss or to find out the format of what, or the form of a quadratic expression. So this is what we shall have. So what is a quadratic expression? Now, a quadratic expression is an expression which takes the general form of ax squared plus bx plus c. So remember, I stop there. I don't continue with what? Equal to something. Why? I'm dealing with what? An expression and not an equation. Are we together? So now, having said that, what is the significance of A, B, and C? We are saying, even before I mention that, there's a key point I must remind you. We have said this is the what? General form of a quadratic expression. But on one condition, the A should not be equal to 0. Now, the B can be equal to 0. The C can be 0, but the A cannot be 0. Why? We are saying the moment the A becomes 0, it means what? This entire term won't exist. If this term with power 2 does not exist, then that is not what? A quadratic expression. So A must be a positive or a negative non-zero value. But B can be 0, B can be a positive value or number, B can be a negative number. C can be 0, a positive number or a negative number. Now, what is A? A is simply the coefficient of x squared. B is the coefficient of x. And C is what we call a constant term. So it means in general, a quadratic expression has how many terms? 3 terms. The quadratic term, which is the ax squared part. Then the linear term, which is the bx part. Then the constant, which is the c. Then the letter not attached to any x. So we have c as the what? Of course, constant. So we have the quadratic term, linear term, and the constant. Are we together? So we are saying, in general, this is the form of what? A quadratic expression. Ax squared plus bx plus c. And our a should not be equal to 0. Now, having known that, and of course now given different quadratic expression, is a very key thing that a student, of course, now masters how to identify an A, the B, and the C in a given quadratic expression. And that's what we are doing next. Are we together? So we'll have our first example of a question. So just put the question down. The question is, you state the value of A, B, and C, of course, in the given quadratic expression, which I'm going to list here. So our first expression is given by 3x squared plus 5x plus 6. So we have 3x squared plus 5x plus 6. So given this expression, can we identify the A, B, and the C? What's our A? The coefficient of x squared. In short, the coefficient of the quadratic x. In this case, what is our a? It is 3. Okay. What about our b? B is the coefficient of the linear x. In this case, what is our b? Our b is 5. Now, what about our c? Our c is the term which is not attached to any x. In this case, what do we have? 6 qualifies to be our c. Now, of course, now with this example, I can term it to be a simple one. Now, I want to look at what I can call maybe complex and see how well we can do it. Be able to identify the a, b, and c. So, like our next one will be 4x squared plus 7. So we have 4x squared plus 7. Now, given such an expression, it might prove a challenge to some students. Why? In the general format, we have how many terms? 3 terms. And yet here we have what? We have 2 terms. But now, having learned the significance of a, b, and c, this should not be a challenge. What is the a? A is coefficient of x squared, coefficient of quadratic x. In this case, what we have? We have 4. So 4 qualifies to be our a. Now, look at b. B is what? Coefficient of the linear x. If you look in our expression, 4x squared plus 7, we don't have what? A linear x. Now, what does that imply? Our b is 0. When the b is 0 here, the entire term becomes 0. Then it's not, of course, shown here. So we are saying, because I don't have linear x, that is what? X to the power 1. Our b becomes what? 0. Then lastly, 7, which is the only term we have not talked about, becomes automatically what? The c. That is the term not attached to any x. So we are saying c is what? Given by 7. Now we look at another example here. Of course, now maybe given a different arrangement, which is maybe not very obvious. Now let us have 5 plus 5 plus 6x minus 2x squared. Remember, when I was giving the general form, we began with the what? Quadratic x. We came to linear x. We came to the constant. Now, number of students now, given a different arrangement, they might now confuse. Now thinking maybe this should be the a, possibly this is the b, and maybe I don't know how even they will get now their c. That would be a challenge. But you're saying, if you just make a clear connection, despite that arrangement being different, as a good student, you're supposed to do what? Be able to identify your a, b, and c. Now, our a, the rule is simple. What's our a? Coefficient of the quadratic x. In our case here now, our quadratic x is at that far end. So what becomes of our a? Negative 2. Are we together? So we say, in this case, a is negative 2. Then we have our b. Our b, as per the rules, still remains what? The coefficient of the linear x. So what's our b? Our linear x is here. What's attached to it? It is 6. So b becomes what? Obviously 6. Then lastly, what becomes of our c? It is 5. So 5 becomes our c. So again, based on the examples I've given now, you can just Put down the following question for practice. You write, state the values of a, that is small a. State the values of a, talking about small a, comma, b. A, b, and c. State the values of a, b, and c in the following quadratic expressions. In the following quadratic expressions. State the values of a, b, and c in the following quadratic expression. So the first question is 5x squared plus 2x minus 6. Number 2, 3x squared plus 4x. The third one we have x squared minus 1. Number 4, we have negative x squared plus 6 plus 5x. I think now those will be enough, of course. Now in terms of what the practice, just to confirm that the concept is home. So we go to our next part. That will be discussing now what the basic things that can be done on an expression. Now I gave 3 things which can be done on an expression. Can you remind me? Number 1, we said you can expand. Number 2, simplify. And number 3, of course, factorize. Now we want to focus on what? Expansion of what? Of course, now dealing with what? Quadratic expressions. So I think before maybe I continue, just be able to remind you of the key things we have talked about. We were focusing on what? Quadratic expressions and equation. We began with clearly noting the differences. What is the difference? An expression has one side, an equation has two sides. So what do you do to expressions? We expand, we simplify, or factorize. What about equations? We solve. Are we together? Simple as that. Now, of course, our focus now is on quadratic expression. Of course, we have discussed the general format and how to identify, of course, the A, B, and the C. Now, we want to discuss the issue of what? Expansion. Something, an operation which is carried out on what? Expressions. So, what's an expansion? I mean, what is the definition of expansion? I'm going to use, of course, now numbers. Then come to what? Algebraic expression. Now, in terms of real numbers, expansion means what? You join smaller units to obtain a bigger unit. I'm going to give an example. We have 2 times 3 to give us what? To give us what? 6. If you're very keen, 2 here is a smaller unit. 3 is a smaller unit. The moment you combine them, what do you come up with? Something bigger than the 2, something bigger than the what? 3. So we are saying, moving from this side to that side, you have done what? You have done expansion. Are we together? And later, we shall discuss the reverse. We'll be doing what? Factorizing or factorization, where you break the 6 into 2 and 3. How do you do that? Very simple. So begin with 2 as the least prime number, which can go in 6. 2 goes in 6 how many times? 3 times. What about 3? 3 goes in 3, of course, 1 time. So I'm insisting, as we move from what? This to that. What do you call that? Expansion. As we reverse, what do you call that? Factorization. Whatever you come up with, what do you call them? Factors. But now, that will be an issue we'll discuss later afterward, covering expansion. Of course now, and having exhausted it, so we shall go to what? Factorization. So can I now focus on expansion? I've given the first definition in terms of what? Real numbers. Now, I want to give now a definition in terms of what? Algebraic expression. You can say expansion is the removal of brackets. So now we have what? We have issues of brackets. So expansion is the removal of brackets. An example, if you have 2 into x plus 3y. Now we have brackets there. Now what is the implication of brackets? Something you've done in board math, you multiply what's inside by what's outside. So begin by multiplying 2 and what? And x to give you 2x. Then plus 2 times 3y to give you what? 6y. If you're very keen now, whatever we have written here, we don't have what? Brackets. Brackets have gone. So we're saying expansion is what? Removal of brackets. But even as you remove the brackets, take care of the what? The roots of integers you covered in Form 1. Of course now, my second example will factor in that particular what? Concept. Example 2 will be a negative 2. Negative 2 into 3 minus 4y. So as you multiply what is here with what is there, take care of the what? Of the sign. This is a negative number, that's positive. Now when you multiply a negative and a positive, what do you get? You get a negative number. So remember such issues covered in Form 1. Don't neglect that. So what do we get? Negative 6. Now here I have negative 2 times. This take it to be negative 4y. What do we get? Changes to plus 8y. So you're saying that is what? Meaning of expansion. Meaning what? We are removing brackets. Is that okay? So having discussed that, we can just look at more examples to make sure the concept is well understood. So let's put on the following examples. Expand the following. Expand the following. The first is x into x plus 3. Number 2, we have x into 5 plus x. And number 3, let's have x into x squared plus x. Let me say x squared plus, sorry, this should be xy. Okay, I think we can maybe just give one more, then we can go through them one by one. The last one is negative 5x into x cubed minus y. Now, the first one, talk about the solution. We have x into x plus 3. What does it mean? X by that x to give you what? To give you x squared. Then x times 3 to give you, of course, 3x. That is the first solution. Now we go to our second question. X into what? 5 plus x. That will be x by 5 to give you 5x. Then x times x to give you x squared. Our third one, if we multiply x times x squared. At this point, you can recall what? Your lots of indices. I'm having this and this having the same base, but now, of course, now the powers are, here we have power 1, we have power 2. So having the same base and you multiply. What do you do in indices? You add the respective powers. So you have 1 plus 2 to give me power 3. So what do you end up with? X cubed. Of course, plus this times that will give you x squared. Of course, now adding 1 to that 1 there to give you x squared y. Sorry. Then the last one, we have the issue of the negative, which now must be affected as you, of course, now expand this. Negative 5x times x cubed. What do we get? Of course, now having the same base here again and power 1 there, you get negative 5 x power 4. This and this will give you what? A plus 5y. So now we've exhausted that. We go to a different part of the expansion. Let me just get the board, then continue. Now, what if you're given an expansion of that nature, which is something like that? So we have x plus 3, of course, times x plus 4. So how do you deal with that? Now, we shall just use the previous idea, of course, now in the question we have just seen. So, of course, I'll do an example on at this point, and then we'll see how we can apply that to this. So, given a question like expand 2 into x plus y. 2 into x plus y. If you look keenly in that expansion, we have two parts. The first part is the 2 we have there. The second part is the x plus y. So what do? You take the 2 times the x to give you what? 2x. Then you take the 2 times the y to give you what? 2y. Now compare this and this. Now the 2 here, of course, now is going to correspond with what? X plus 3. So this is like our 2 in this case. What about the x plus 4? Corresponds with what? The x plus y. Of course, in the other example I've given you there. So what do? Here we took the 2 times the first term in that bracket. Here we shall take x plus 3 times the first term in that bracket. So what will you get? We shall have x plus 3 times x. Then we had 2 times x. Then plus, here we have what? X plus 3 times x. Then we take what? Plus. The same x plus 3 times the second term in the second bracket to give you what? Given by 4. So multiply this and that to give you what? X squared. Multiply this by that to give you 3x. Then multiply 4 by that to give you 4x. Lastly, multiply 4 by 3 to give you what? 12. Then you put like terms together. Now, what's the definition of like terms? Like terms means what? Terms that have similar letter composition raised to the same power. For example, this and this are not like terms. Why? We have power 1, we have power 2. But now, this and this are like terms. So, put this and this together to give you what? 7x. So, in the end, what do we have? We have x squared plus 7x plus 12. That's what we get. So having understood the expansion of this from expansion of that, now we can make this expansion simpler. This is what you do to make it simpler. So given such an expansion or such an expression and required to expand, this is the easier, of course, now approach. We have x plus 3, then times, of course, brackets means what? It implies you multiply. So x plus 3 times x plus 4. So what shall we have? So x plus 3 times x plus 4. This is the easy approach. Of course, now the first approach was just to connect the previous, of course, now expansion case with what we have here. But now, given this question, this is the easy approach. You take the first term of the first bracket. In this case, given by what? Given by x. Times the entire second bracket given by x plus 4. And then you take plus 3, focusing on what? The second term in the first bracket, of course, together with that sign which is there, into that. Then now you complete your statement by doing what? Completely removing the brackets. So what shall we get here? X squared plus 4x plus 3x plus 12. Then again, put like terms together. Like terms doing what? This and that. So what do you get? We get x squared plus 7x plus 12. How do you get 7x? Combine the 4x and the 3x, which qualify to be what? Like terms. So that becomes what? That becomes our final answer, which is similar to that, but now this is what? A simpler approach. Is that okay? So we've learned how to expand, of course, given, of course, now expression of this nature. Now just maybe give you a question or two, then we go to something else. So put down the following questions. Expand. Expand the following. Expand the following. So I give 3 or 4. Then wait for. Expand the following. Then wait for your response. Then we continue. X plus 2. Of course, times x minus, let me say we have 7, sorry. We have number 2, 3x plus 2. Times 5x plus 7. Then lastly, let's have 9 minus 4x. Times 2 plus 3y. So just a few minutes, and of course now we go through them quickly. So what do you do here? In the first case, let's have the, of course we are expanding. We have the solutions. So what do you do here? You take x times the second bracket. Are we together? So what shall we have? X into x minus 7. Then plus whatever we have here, plus 2 times the entire second bracket. Then we proceed. So x by x will give us what? X squared. Then x by 7 minus 7x. Then 2 by x, 2x minus 14. Now identify the like terms, that is negative 7x plus 2x. Now here the issue of integers now will be tested. So having an issue with integers can give you a problem in terms of how you finish this. So what is negative 7x plus 2x? Yeah? You get negative 5x. So what becomes our final answer? X squared, of course, minus 5x minus 14. Do you agree? Okay. So this is the first, the expansion of our first. Of course, now question there. We go to the second question. The approach will be similar to that. So you take the first term in the first bracket times the entire second bracket. So what shall we have here? 3x times, we said, the entire second bracket given by 5x plus 7. Then we close the bracket. Then we go to what? The second term in our first bracket, that is, we take plus 2 again times the entire second bracket given by 5x plus 7. Now, remove the brackets completely. This by that, what do you get? 15x squared. Sorry. This by that will give you 21x. Now, 2 by 5x, what do you get? 10x. Then 2 by 7 gives you 14. Then your like terms. In this case, what do you have as a like terms? 21x and 10x. When you put them together, what do you get? 31x. So, what should be your final answer? 15x squared. Plus 31x plus 14. Is that okay? Good. So I believe now you can do this one on your own. Okay. So we're done with the what? Expansion. Now we are going to one of the key areas. Of course, now in terms of application questions, it's called quadratic identities. Now, I've given the definition of an identity there. So I'm just going to read it to you. An identity is what? An equality that holds true regardless of the values chosen for its variable. Are we together? It's something you can apply in many occasions, just by the way it's framed. Are we together? Like I give a simple example. At least you know me, I'm your teacher here. Are we together? Now, if I told you to find 2 ID cards, maybe you're walking, you find like a lost item, a wallet, then there are 2. You find some 2 IDs there. If you find my ID and ID that belongs to somebody else, which one can you be able to pick it? Mine. Why? You can maybe identify with it. Why? You see a face similar to mine, you see a name similar to mine. So you compare the details there with the ones you know, and you can easily identify with them and maybe be able to pick it. So a similar thing will happen here. There's something I'll give you, then you see it and you can be able to remember what? Of course, that you have seen it somewhere. And maybe this is how it's supposed to be from the way you have learned in the past. So I think here I'm saying pay close attention as I try to do what? Explain this.